The Foundations of Geometry by David Hilbert. Chapter 2. The Compatibility and Mutual Independence of the Axioms. Section 11. Independence of the Axioms of Congruence. We shall show the independence of the axioms of congruence by demonstrating that Axiom 4, 6, or what amounts to the same thing, that the first theorem of congruence for triangles, theorem 10, cannot be deduced from the remaining axioms 1, 2, 3, 4, 1 through 5, and 5 by any logical process of reasoning. Select as the points, straight lines, and planes of our new geometry of space the points, straight lines, and planes of ordinary geometry, and define the laying off of an angle as in ordinary geometry, for example, as explained in section 9. We will, however, define the laying off of segments in another manner. Let a sub 1 and a sub 2 be two points which, in ordinary geometry, have the coordinates x sub 1, y sub 1, z sub 1, and x sub 2, y sub 2, and z sub 2, respectively. We will now define the length of the segment a sub 1, a sub 2 as the positive value of the expression, the square root of the quantity x sub 1 minus x sub 2 plus y sub 1 minus y sub 2 squared, plus the quantity y sub 1 minus y sub 2 squared, plus the quantity z sub 1 minus z sub 2 squared, and call the two segments a sub 1, a sub 2, and a sub 1 prime and a sub 2 prime congruent when they have equal lengths in the sense just defined. It is at once evident that in the geometry of space thus defined, the axioms 1, 2, 3, 4, 1, 2, 4, and 5 are all fulfilled. In order to show that axiom 4, 3 also holds, we select an arbitrary straight line A, and upon it 3 points a sub 1, a sub 2, and a sub 3, so that a sub 2 shall lie between a sub 1 and a sub 3. Let the points x, y, and z of the straight line A be given by means of the equations. X is equal to lambda t plus lambda prime, y equals mu t plus mu prime, and z is equal to nu t plus nu prime, where lambda, lambda prime, mu, and mu prime, nu, and nu prime represent certain constants, and t is a parameter. If t sub 1, t sub 2, which is less than t sub 1, t sub 3, which is less than t sub 2, are the values of the parameters corresponding to the points a sub 1, a sub 2, a sub 3, we have as the lengths of the three segments a sub 1, a sub 2, a sub 2, a sub 3, and a sub 1, a sub 3, respectively, the following values. The quantity t sub 1 minus t sub 2 times the positive square root of the quantity lambda plus mu squared plus nu squared. The quantity t sub 2 minus t sub 3 times the positive square root of the quantity lambda plus mu squared plus nu squared. The quantity t sub 1 minus t sub 3 times the positive square root of the quantity lambda plus mu squared plus nu squared. Consequently, the lengths of a sub 1, a sub 3 is equal to the sum of the lengths of the segments a sub 1, a sub 2, and a sub 2, a sub 3. But this result is equivalent to the existence of axiom 4, 3. Axiom 4, 6, or rather the first theorem of congruence for triangles, is not always fulfilled in this geometry. Consider, for example, in the plane z equals 0, the 4 points, O having the coordinates x equals 0, y equals 0, A having the coordinates x equals 1, y equals 0, B having the coordinates x equals 0, y equals 1, C having the coordinates x equals 1/2, y equals 1/2. Then, in the right triangles OAC and OBC, the angles at C as also the adjacent sides AC and BC are respectively congruent, for the side OC is common to the two triangles, and the sides AC and BC have the same lengths, namely 1/2. However, the third sides OA and OB have the lengths 1 and the square root of 2 respectively, and are not therefore congruent. It is not difficult to find in this geometry two triangles for which axiom 4,6 itself is not valid. The Foundations of Geometry by David Hilbert. The material contained in the following translation was given in substance by Professor Hilbert as a course of lectures on Euclidean geometry at the University of Göttingen during the winter semester of 1898 and 1899. It was translated by E. J. Townsend, Ph.D., University of Illinois. The text was downloaded from Project Gutenberg with the following notice: this ebook is for the use of anyone, anywhere in the United States and most other parts of the world at no cost and with almost no restrictions whatsoever. Read by Jim Renholt. Programming and illustrations by Jim Renholt. 2019. Portrait of David Hilbert by Rita Ray Renholt. Thank you for listening.